Hello, my name is Ramon and I will be talking about the different types of derivatives. Mostly I will be talking about how to derive when you have a trigonometric function inside of a function. For example, we have f of x is equal to x times secant of x. As you can see, it's no ordinary function because it has the multiplication and also a secant function, a trigonometric function. So, to derive when you have a multiplication, you have f of x is equal to the multiplication of two different functions. For example, we have g of x times h of x. In this case, g of x is equal to x, and h of x is equal to secant of x. So, to derive f of x, we would first need to find the derivatives of both of these functions. So, in this case, g of x, g prime of x is equal to 1. And h prime of x is equal to the derivative of secant is tangent of x times secant of x. So, f prime of x is equal to, when you have a multiplication, you have this equation, h of x, which is secant of x, times the derivative of g of x, which is 1, plus g of x, which is x, times the derivative of h of x, which is tangent times secant. So x times tangent of x times secant of x. And when you simplify this, you have f prime of x is equal to secant of x plus x times tangent of x times secant of x. And this would be your derivative. But what would happen if you didn't know what secant of x? Let's try this again. We have the same thing. F of x is equal to x times secant of x. So you know that g of x is equal to x. And you know that h of x is equal to secant of x. So, what would happen if you didn't know the derivative of h of x? Well, we know that secant is also 1 over cosine of x. So if we know this, then we know what the derivative of cosine is. So when we unite these two, we have f of x is equal to x over cosine of x. And now we have two different functions of which we know the derivatives. So we have f of x is equal to x over cosine of x. Now, we have a division of two functions. So what we do is when we're finding the derivative of such functions, we have the denominator times the derivative of x. So g of x is equal to x, and g prime of x is equal to 1. So it's the function that's in the denominator times the derivative of the numerator. So it's cosine of x times 1 minus the function that is in the numerator, x, times the derivative of the denominator. And the derivative of cosine is negative sine. So x times negative sine of x. and this goes over the denominator squared. So we have cosine of x squared. Now when we simplify this, f prime of x, we have cosine of x minus, no, plus x, so negative times negative is a positive, and x times sine of x is x sine of x. And we have over cosine squared of x. So you can simplify this even more, because when you separate this and this and this, you have x prime of x is equal to cosine of x over cosine squared of x plus x sine of x over cosine squared of x. Okay, so this one eliminates and you have 1 over cosine f prime of x is equal to 1 over cosine of x plus, you can separate these, x times sine over cosine and then would be 1 over cosine that is going to be left over. So 1 over cosine of x. So when you simplify, f of x, f prime of x is equal to 1 over cosine is the same thing as secant of x plus x times sine over cosine is tangent, and 1 over cosine is secant of x. And as you can see, now we have the same result as what we did before, but this one's easier if you don't know all of the trigonometric derivatives. So now that we have this, let's try another example. Let's say we have f of x is equal to tangent of the square root of x squared plus 5. Okay, so if you know the derivative of tangent is if f of x is equal to tangent, f prime of x is equal to secant squared of x. So we have, okay, but we have tangent of another function. So what we have here is the chain rule. So what we have to do is separate these two functions. So f of x is equal to g of x composed of h of x. So if we separate them, we have g of x is equal to tangent of x, and h of x is equal to square root of x squared plus 5. Okay, so now to derive this, we have to find the derivative of both of these. So the derivative of tangent, as I said earlier, g prime of x is equal to secant squared of x. And okay, but now what do we have here? We have another function that is composed because we have the square root of another function. So this one we have to separate also. So h of x, we can separate this into j of x equal to the square root of x, and k of x is equal to x squared plus 5. Okay, so to derive this, now we have to find the derivative of both of these functions. So the derivative of j of x, j prime of x is equal to, so this is j of x is the same thing, okay, square root of x is the same thing as saying 1 x to the 1 half. And j prime of x would be the exponent 1 half times x to the negative 1 half. And this is the same thing as j prime of x is equal to 1 over 2 square root of x. So we have the derivative of j of x. So now we derive k of x. So k prime of x is equal to 2x. So we have that. Okay, now we have these two derivatives. So as we said, j of x, j prime of x is equal to 1 over 2 square root of x. And k prime of x is equal to 2x. Okay, so to derive h of x, we need to use the chain rule. And what the chain rule says is that h of x, h prime of x is equal to, if we have j composed of k of x, then what the chain rule says that the derivative of h of x is the derivative of what's inside the function, or k of x, the derivative of k of x times the derivative of this complete function. So the derivative of j of x composed of k of x, or j prime of k of x. So now we substitute these values. So we have that h prime of x is equal to, what is k prime of x? 2x. Times, what is j prime of x? 1 over 2 square root, and since it's j composed of k of x, so we substitute k of x, which is x squared plus 5. So now we have that h prime of x is equal to 2x times 1 over 2 times the square root of x squared plus 5. So now we simplify. H prime of x is equal to 2x over 2 times the square root of x squared plus 5. And we simplify even more. H prime of x is equal to x over the square root of x squared plus 5. So now we have that derivative. So we have these two, and since we already have this, we can forget about these two derivatives. So we have h prime of x is equal to x over the square root of x squared plus 5, and we also have g prime of x, which is secant squared of x. As I said earlier, let me change this so you can understand it better. We have g of x, g composed of h of x. So as we said earlier, g, the complete function, is tangent of x, of a variable. So g of x is equal to tangent of x. And we have that h of x is this function inside of here. So h of x is equal to square root of x squared plus 5. So to derive this, we also have to use the chain function, the chain rule. So f prime of x, according to the chain rule, would be the derivative of what's inside of the function, h prime of x, times the derivative of the complete function. So g prime of the composition of h of x. Okay? So now we substitute the values. F prime of x is equal to h prime of x is x over the square root of x squared plus 5, and we multiply it times g prime, which is secant squared, and composed of gx, so of hx. And hx is square root of x squared plus 5. So we have this. So now what we do is simplify. So 8 prime of x is equal to x times the secant squared of the square root of x squared plus 5 over the square root of x squared plus 5. And this would be the derivative of f prime of f of x.